All right, so I look at this problem and it's not as easy as it's been. It's not as easy as a power rule or something. So the first strategy you should always try from now on with integration problems is U-substitution. So the whole point is that you're going to make the problem easier to integrate by substituting R, whatever your variable is, with U, or like some people like to call it, go to U world. So I came up with this little acronym for you guys. It's called CUP. So C stands for what you care about, U stands for put everything in terms of U, and then P stands for plug U back in at the end of the problem. So C is what I care about. This is everything that I actually might care about. I might not need everything. And by everything, I mean I might just not need this part, but everything else you're going to need. So the whole point here, another thing I wanted to mention, is that I always write it as dx and x, but really this variable is whatever the variable is in your problem. So if the problem has an r in it, then this is really dr, okay? So the first thing you need to do is obviously find your u. So I look at this and I'm like, okay, what's the trickiest part about this problem? Well, it's really this, but you'll notice after doing a lot of problems, what you really want to make your u is what's on the inside. So I'm going to make my u r squared plus 9. Okay, so then the next part is find du. And so du is really just the derivative and then you add a dr there. But you might be confused. You might be like, where did the dr come from? And this is basically where a lot of professors just skip this step. They don't really show you what's going on. What you're really doing, actually let's start this way. Let's say you have y is equal to 2x. I tell you to find the derivative, well, you say y prime is 2. Another way to write that is dy dx is 2. Remember that notation? The derivative of the function y with respect to x, because the terms are x, is 2. So same thing, if you have u is equal to r squared plus 9, okay, and I tell you find the derivative of u, well, you could do u prime is equal to 2r. But you could also do the derivative of the function u, or the equation, whatever, with respect to r, because the variable is r, is dr. So guess where du comes from, guys? It's literally this. You take the derivative and you solve for du. So times dr to cancel that out. Do the same thing on the other side, and you end up with du is equal to 2r dr. But a lot of professors skip this step because it's just easier to say, hey, find the derivative of this, plug it in here, add a dr at the end, and that's your du, okay? And that's also what I do. But I really wanted to show you the steps because it's just, I got so confused in the beginning. I was like, where did the dr come from? But that's really where it came from. But why do we need du? Because we need to solve for dr. So dr is really just du divided by 2r. You take this and solve for dr, right? So divide by 2r, and you're left with dr is equal to du over 2r. Alrighty. So then I might not always need r. So this is my strategy. I never solve for r, or whatever variable your problem has, until I go to this step. And if this step doesn't if things don't cancel out, then I go here and this might help me. All right. So I'll show you what I'm talking about. So u, the u part of cup, is put everything in terms of u. So literally make this, but in u. Okay. So the integral of 4r, and I know I said everything in terms of u, but bear with me. This we said was going to be u. So that's u squared. Okay, and then dr, we literally have dr in terms of u. Dr is du over 2r. Now here's the point. The reason I didn't solve for r is because a lot of the times, literally most of the time, it's just going to cancel out, okay? Things are going to cancel out, and then you didn't even have to solve for r. You didn't even have to do this step, right? So this is everything that you care about, or that you might care about, but it's not everything that you're going to need, right? So I just like to put it there because I got confused in the beginning when my professors were teaching U-Sub and they were just using things in one problem and then not using things in the other. I was like, well, what do we really need, you know? So this is everything that you might need, but not everything that you're gonna need, okay? And so the r cancels out, right? If it didn't cancel out, then for some problems, there's things that are not gonna cancel out. It either means U-Sub just does not work, move on to another integration technique, which we will learn in Calc 2, or just solve for r here, and that's going to help you, okay? So then another thing is that you have these two numbers here, 4 and 2. This is really the same thing as make this 1, 4 divided by 2, right? So you could just bring these two numbers out, right? 4 divided by 2, which is really just 2. So that's going to be 4 divided by 2, which is just 2. That's an integration little rule there you could do. And so du over 1 just becomes du. And then you have this. And so notice everything is literally in terms of u. This is this, but in terms of u. So if you have any variable that's not r, after you cancel things out, you did something wrong. You're not supposed to have that. Everything is supposed to be in terms of u, okay, at this point. And then you integrate. You take your antiderivative. I like to simplify, take advantage of my power rules here. So make it a power, because this is really just this. All right, and then plus 1, negative 2 plus 1 is negative 1, so we have u to the negative 1, and then divide by whatever this is, that's negative 1, or multiply by its reciprocal, whatever you like. So that's that, so it's really just that, and remember we're multiplying everything by 2, and we add a plus c because it's an indefinite interval. It's indefinite because I see that there are no bounds, right? There's no numbers like 1 and 2 or something, right? So it's indefinite, you add a plus c at the end of your answer. And so this is my answer to this problem, but it's in terms of u, so that's why we have the p part in cup, and it's really just saying, hey, plug u back in. So we have u, and I'm actually going to rewrite it to be negative 1 over u plus c, so we can make things easier. I could also distribute the 2n. This should have been this part here. Okay, I could distribute the 2n, so this becomes just negative 2 over u plus c, and then, okay, and then I plug in my u, right? My u is r squared plus 9, and now this is my answer to this integration problem, but in terms of the original variable, because remember, U-sub is just a strategy to help make integrating things easier, but your actual problem, the solution should be in terms of r, right? And that is how you do U-sub. We'll do a definite integral U-sub in the next video. Hopefully you found this helpful, and I'll see you in the next.